Hey everybody, my name is Andrew Lambert, and for my Physics 106 presentation, I'm going to be teaching about the structure of the nucleus of an atom. So before we can get into what a nucleus is made out of and where it gets its properties from, we need to talk about the history behind the nucleus and how it came to be. So way back in the day, there was a physicist named John Dalton, and he theorized that there was a small particle that made everything up, that everything was made of identical materials, like a bar of iron was made out of the same material as another bar of iron. Everything was the same, and that a tree outside was made out of the same material as every other tree. And these small materials he decided to call atoms, based off the word atomos from ancient Greek, which means indivisible. And he said that this was the smallest building block there could possibly be of the universe. This is it. There's nothing smaller, nothing can split these things. Um, and that's what people believed for about 100 years. And then in 1904, J.J. Thomson, another physicist, discovered the electron, which then debunked John Dalton's theory that the atom was the smallest building block of history or of the physical world. And J.J. Thomson theorized that atoms were actually just a spherical positive charge. And the electrons were peppered throughout the entire sphere to make it a net neutral charge. And he called this the plum pudding model because it looked like, or he thought it looked like, the spherical charge was just shotgunned with these negative electrons that helped balance it out and keep everything neutral. But just a few short years later, Ernest Rutherford uh, discovered his own theory and performed experiments to discover what we now know as the nucleus of an atom. What Rutherford did was he put a radioactive material in a box and pointed that box towards a sheet of gold foil that was surrounded by a detector that could detect atomic materials. And these particles would be shot towards this gold foil, and a bunch of them passed straight through, and were shown on the opposite side of the detector from the radioactive material. But and so that proved that atoms were composed mostly of empty space, and that there was a lot of space for atoms to pass through. But there were some particles that would veer off and change direction after passing through the gold foil, and that proved that the charge was positive in the nucleus, or they were of the like charge, and so they were able to repel each other and send each other flying different directions. But every once in a while, a radioactive isotope or an alpha particle would bounce back off the gold foil and come back towards Rutherford. And that proved to him that the nucleus of an atom carries mass, saying that the nucleus was lined up perfectly and it hit another nucleus of the gold foil and bounced back towards him. And that's where we got the idea of a nucleus, and the idea that nucleus or nuclei have mass and substance to them rather than just being a cloud of positive charge. So the actual composition of a nucleus is made of two different things, protons and neutrons. They are both relatively the same size, a proton being 1.007 atomic mass units and neutrons being 1.008 atomic mass units. So you can say they're basically the same size. It's splitting hairs when saying one is heavier than the other. But the main characteristic difference of the two is that protons carry a positive one charge with each proton. And so when you change the amount of protons in an atom and change the protons in a nucleus, you're actually changing the properties of an atom. If you add one proton to a nitrogen atom, you get oxygen. But if you change the numbers of neutrons in a nucleus, you just change the stability of the atom. You create isotopes of that atom and change the physical properties, or you change some of the stability properties, not necessarily the physical properties of that atom. Now, we learned in this class that like charges repel each other. So common sense would say that protons would repel out of the nucleus, and it doesn't make sense that the nucleus can stay together. But scientists and physicists have recently discovered that there's something called a strong nuclear force that keeps nuclei together. Not much is known about this force other than the fact that it works in the nucleus, And we also know that it works only on these small degrees of mass. So when you're talking about one atomic mass unit size scale for the force be acting on, that's when it works. And that's when they're that close together, when they are very close together, that these things can be held together and overcome the electrostatic repulsion that normally comes from different or from like charges being close together. And that is how the nucleus is held together, what it's made of, and how the ideology of the nucleus came to be. And these are my references of where I found my information in the graphics, and thanks for listening.